The latest release of Apache Kafka is here, and it's packed with 38 KIPs, including some major features that are now production ready, alongside a number of improvements to the platform, continuing this theme of cloud-native Kafka. Hi, I'm Sandon Jacobs, developer advocate at Confluent, here to hit the highlights of Kafka version 4.2. So, let's get into it. Queues for Kafka adds some key improvements to make it ready for prime time. Now, if you're interested in a deep dive of Queues for Kafka, we'll provide a link to a video where I unpack the inner workings of this new shared consumer model. Here are a couple of new enhancements to queues in Kafka 4.2. All of your processing workloads aren't created equally. Maybe we're calling a third-party partner integration or an AI model, cases where the processing time could be measured in dozens of seconds, or maybe even longer than a minute. For long-running tasks, KIP 12.22 provides a new acknowledgement type that allows developers to renew the lock on acquired messages. Now, this new acknowledgement type only applies when you're using the explicit acknowledgement mode in your consumer configuration. For any given message, this means the processing application can tell the broker that we're still working on this message and we may need a little more time. The message is still an acquired state, meaning another consumer instance can't fetch it, and this helps prevent possible duplicate processing. Once that message is processed, the consumer can acknowledge the message and continue working on others in the queue. In distributed event-driven systems, I think we can all agree that observability is non-negotiable. Those are just table stakes. If you recall, the main motivation of KIP 932 is this ability to scale consumption beyond the number of topic partitions. But when and based on what metrics? Well, KIP 1226 exposes new shared consumer lag metrics. Similar to the lag metrics of your traditional Kafka consumer groups, this feature gives us insights into the progress of our shared consumers. This is the data you need to determine if and when your consumers should scale up, perhaps during a spike in volume, and just as importantly, when they can potentially scale down to save you money on compute. Look for auto-scalers from your cloud provider and the open source community to leverage this lag metric in the near future. And with that, Kafka makes your queue workloads a first-class citizen. You can simplify your code base and architecture by unifying your event streaming and point-to-point messaging use cases in Apache Kafka. Broker-driven rebalancing comes to Kafka Streams applications in KIP 1071. Now, if that sounds familiar to you, it's because this builds on the changes introduced by KIP 848, which move coordination of rebalancing consumers from the client side to your Kafka brokers. KIP 1071 extends this model to your stream processing workloads. It introduces a new Streams group protocol with new admin tools and APIs to describe these Streams groups. There's also new metrics to add task-level visibility in your Streams applications. Keep an eye out for more enhancements like support for dynamic topology updates, warm-up task, and regex topic lookup in future Kafka releases. Speaking of rebalancing, improvements to KIP 848 continue towards the goal of it becoming the default rebalancing protocol for Kafka consumers. This release hardens a number of performance edge cases specifically around the async Kafka consumer. I strongly encourage you to make the move to this next generation rebalancing protocol to take advantage of this broker-side functionality. Let's pivot back to Kafka Streams. New error handling in KIP 1034 allows Streams applications to route events to a dead letter queue. Or is that a dead letter topic? Yeah, a DLQ topic. Anyway. Until now, the options for exception handling were to 1. Fail the app, 2. Log the event and move on, or 3. Roll your own DLQ mechanism. With this feature, you create a new topic in your Kafka cluster, then add this new topic name as the dead letter topic in your Streams configuration. From there, the default exception handler will create and send a DLQ message to this topic. Now, this DLQ message includes the original key and value, along with information about the exception that got us here in the first place. Now you, the developer, get to decide how to handle these exceptional events. Most configuration classes in Kafka Streams follow the Fluent API pattern, but close options was a bit of an outlier. KIP 1153 refactors close options to be consistent in style with those other config classes. But this KIP goes beyond just style. It provides a more flexible and explicit way to control consumer group membership and topology shutdown behavior. Those are some of the highlights of Apache Kafka version 4.2. This release also includes a number of enhancements for efficiency, operations, and observability. There's new functions so that operators can quickly query internal broker properties. There's also improvements to rack awareness for Kafka consumers. A lot more than I can fit into a short video. So check the description for links to the release notes, our Confluent blog about the release, and Confluent Developer. Now that's your go-to resource for all things event streaming, including free tutorials, courses, and videos from our team of experts. Thanks for watching, and bye for now.